Hi there, and welcome to this lesson. Now, in this lesson, we're learning about functions and graphs, okay? And under functions and graphs, we're learning the graphical solutions of quadratic equations, okay? So, at this point, I'd remind you to set the video to play in 1080p HD so you can see everything clearly. And as the lesson progresses, if you have any issues at all, anything comes of us unclear, please feel free to get in touch. Okay, you can do so via the course dashboard. Okay, let's jump right into the lesson. So functions and graphs, graphical solutions of quadratic equations. Now consider the quadratic equation x squared minus x minus 6 equals 0. Now you can pretty much go ahead and solve this using either the factorization method, the completing the square method, or the formula method. Okay, and once you do so, you would find the answers x equals minus 2 and x equals 3. Now there is another way we can actually go about doing this. Okay, so we can solve this quadratic equation using a graph. Okay, and that graph would be the graph of the function y equals x squared minus x minus 6. Okay, and in this case we're given a range, okay, minus 3 to minus 3 to 4. So basically we're going to plot the graph of the function y equals x squared minus x minus 6 for the range x moving from minus 3 up until 4. So first we need to get our table out. Okay, so for the function x y equals x squared minus x minus 6, we have x values. X equals minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. Okay, and once we put x into the function x squared minus x minus 6, we have that for minus 3 y is 6. Okay, so minus 3 squared minus minus 3 minus 6 will give you 6. And then we have for minus 2, when you put minus 2 for x into that function there, you end up with 0. Okay, and then you do the same for minus 1, 0, 1, 2, 3, and then 4. And now we have our x and y values. We can go ahead and plot our graph. So we have a graph, and the graph of y equals x squared minus x minus 6, and our scale on the x-axis is 2 centimeters to 1 unit, and our scale on the y-axis is 2 centimeters to 5 units. Now let's go ahead and plot our graph. So at the point where we have minus 3 is 6. Okay, so just over 5. All right, remember in this case we have 5 lines between each box, so we just count 1, 2, 3, 4, 5. Yes, we have 5 lines between each box. And you just, for 6, because the difference in this case is 5, for 6 we're just going to count 1 above 5, and basically we have 6 at that point. Okay, so one small line above 5. And then for minus 2 is at 0. Okay, so we have I think you really can't see, but there is a dot, minus 2 right there. Okay, and then for minus 1 is at minus 4. Okay, 0 is at minus 6, 1 is at minus 6, 2 is at minus 4, 3 is at 0, 4 is at 6. Okay, and now we have all our points. We just need to go ahead and join these points. Now if you look at this, the points that we have here, you would agree with me that we definitely cannot join these points using a straight line. Okay, and that's one thing you need to know about quadratic functions. Quadratic functions produce curves, they don't produce lines. Okay, so what you're going to try and do here is you're actually going to try and join this using a smooth curve, and I'll show you exactly how to do that now. So we have a smooth curve from the left to the right. Okay, so you just try to join all the lines. You can use a French curve, okay, but French curves are often difficult to use, but you could just trace it with your hand smoothly. You have to go very smoothly to join all the points together. Now that we have plotted the graph of the function y equals x squared minus x minus 6, you probably already noticed it. Now look at the point where the curve cuts the x-axis. Okay, look at the point where the curve cuts the x-axis. These points, it cuts the x-axis at minus 2 and 3, which, if you recall, are the solutions to our quadratic equation. So anytime you're looking to solve a quadratic equation using a graph, you just plot the function, the related function of that quadratic equation, and the 2 points where the curve would always cut the x-axis at 2 points, and the 2 points where the curve cuts the x-axis is your, or are your, solutions. Okay, in this case -2 and 3. Let's go ahead and solve an example. So example 1, and example 1 says plot the graph of the function y equals 2x squared minus 3x minus 2 for the range -2 is less than x, less than basically from -2 up until 3. Now use the graph to solve the equation 2x squared minus 3x minus 2 equals 0. Now the first thing we want to do is we want to get our table, okay, for x values from -2 up until 3. And if you insert -2 into 2x squared minus 3x minus 2 for x, you would end up with a y value 12. If you do the same for -1, you would end up with a y value 3, and so on up until you get to 3, and the y value in that case is 7. So now that we have our x and y values, we can go ahead and plot our graph. Okay, and we have a graph. The graph of y equals 2x squared minus 3x minus 2. The scale on the y-axis is 2 centimeters to 2 units. Okay, we're counting in twos. And then the scale on the x-axis is 2 centimeters to 1 unit. Now, let's start plotting our graph. Now we have -2 is 12. Okay, so -2 is all the way up there at 12. Okay, basically you have 10, the next one up there will be 12, but it's not written there, but that's okay. So 12, and then we have -1 as 3, okay, all the way down to 3. Okay, so 3 will be between 2 and 4, and then we have 0 as -2. Okay, it's right there on -2, so 0 and -2, and then we have 1 and -3. Okay, and then we have 2 and 0, it's right there on 2, and then we have 3 and 7, so 7 would be between 6 and 8, so 3 and 7. Now, okay, we have some very funny looking points here, but then we can go ahead and join them using a smooth curve. Okay, so you join them using a smooth curve like that, and we're looking for the point where this curve cuts the horizontal axis. And basically we have those 2 points at, I think between 0 and -1 we should have -0.5 there. Okay, and 2. So the two solutions to this quadratic equation is -0.5 and 2. Yeah, so now one thing you may be asked sometimes, okay, sometimes you could be given an equation like this, asked to plot the graph, is you may be asked to find the minimum point, okay, or the minimum point basically. And what you do there, it's pretty much the point, this point here, the point at which the curving point, basically the minimum, the point of curvature, and basically it's the point where the curve curves down and then back up. And basically in this case, if we look, it looks very much like we have a y value at 3.2. Okay, it's just something worth noting. You could be asked sometimes to find the minimum point of the curve. And yeah, that should bring us to the end of this lesson. It's a very simple principle. Basically, you could solve quadratic equations using graphs. Once you plot the function on a graph, you pretty much just look for the 2 points where the curve cuts the horizontal x-axis. Bye for now.